Hello, viewers. This topic is about free fall. So, when a parachutist jump from the aeroplane, so how many phases are there? In how many phases we can study the motion of the parachutist? So, basically, the motion of the parachutist while jumping and coming down to the ground that can be studied in three different phases. So, we can understand the three different phases from the speed time graph. So in the speed time graph, the motion of the parachutist, that is free fall motion. So when a parachutist jump out of an aeroplane but does not open his parachute until some time has elapsed. So parachute is still not open. So parachute is open after some time. So how the speed time graph can be described for that moment of time. We will study that. And this is the graph, speed time graph for the parachutist coming down, but the parachute is not open for a few minutes, right? And of course, the parachutist open the parachute and then he comes down with the parachute with some different speed, right? And that is the second phase. And finally, while reaching the ground or just before reaching the ground, there is another phase, the third phase, when the parachute comes down with a constant speed, right? So there are three different phases. The first phase is from O to A, and the second phase is from A to B, and third phase from B to C, and then there is a fourth phase also from C to D. So let us understand all these phases, what is the meaning, the physics behind these phases one by one. So the first point, the value of the acceleration immediately after he has jumped from the aeroplane is 10 meter per second square. That is the acceleration due to gravity. Gravity attracts everything towards the center of Earth with a gravitational force, and the acceleration in that gravitational force is 10 meter per second square. So this is the acceleration. The exact value of acceleration is 9.81 meter per second square. But to make our calculations easy or to make our calculations simple, we use 10 meter per second square. Second point, the acceleration decreases until point A on the graph is reached. So acceleration decreases till this point. Acceleration decreases until point A on the graph is reached. This is because the graph becomes less steep or the gradient decreases. So the gradient of the this from O to A, that is decreasing. So due to the decrease in the gradient, we will say the acceleration from O to A that decreases, because here from O to A gradient, basically that is the acceleration. The parachutist speed in region AB is constant. Now, in this region AB, the speed is constant. So you see at point A, the maximum speed with which the parachutist comes down, the maximum attraction by the earth, so the maximum force on the parachutist, so the maximum speed of the parachute, that is at point A. Now from point A to B, the parachutist comes down with a constant speed, and that speed here, it is terminal speed. So from A to B, it is a terminal speed. And then the force on the parachute in the region AB, there is no resultant force. There is no resultant force on the parachute, means the downward force due to the weight of the parachutist, that is balanced by the upward force by the air pressure. So there is a resultant force on the parachutist in between A and B, that is zero, right? So there is no net force, means upward force by the air pressure, that is balanced by the downward force produced by the weight. So net force in this region on the parachutist is zero, and this is the reason of terminal speed. Because of net force is zero, so that's why the parachutist is coming down with a constant speed or a terminal speed. The point at which the parachutist open his parachute, that is the point B. Now this is the point B. So after this time, you see, if we drop a perpendicular from B on the time axis, so this is the time when the parachutist open the parachute. When the parachutist open the parachute, so this is that time. And now from B to C, the parachutist come down with the parachute open. So point at which the parachute open his parachute, that is point B. The speed decreases from B to D, because the parachute that has the large area, so the upward air pressure that will be more on the parachute. So due to that, the speed of the parachute is that will decrease. So now it will come down with a less speed. So from B to C, it's a decrease in speed, B to C. So speed is decreasing. You see at A and B, the speed is the highest speed, and then at C, that is the minimum speed. So at C, the parachutist come down with the minimum speed. So from B to C, speed is decreasing. So this is the reason of negative acceleration. From O to A, the reason is of positive acceleration. The speed is increasing. The speed is increasing. So the air resistance is bigger than the now in this region, the air pressure is more than the weight of the person, right? So because the upward force is more than the downward force, so that's why the speed reduces, and this is a reason of negative acceleration. Now again from C to D, this is another terminal speed. Now again, the upward force due to the air pressure and the downward force due to the weight, they are balanced again from C to D. Now again from C to D, the parachutist come down with the constant speed or the terminal speed. So we can understand uh, this graph in a more easy way. So the moment the parachutist jump, this or the skydiver accelerate as they begin to fall. The moment they jump, so they get a acceleration, and they get the acceleration which is equal to the acceleration produced by the earth, 9.8 meter per second square. And to make our calculations easy, normally we use 10 meter per second square. So at this point on the speed time graph, at this point, the moment the skydiver or the parachutist jump from the aeroplane, at that moment, there is a acceleration which is equal to 10 meters per second square. Now, at this point on the graph, as the skydiver speeds up, the air resistance force increase. So as the speed of the skydiver or the parachutist that increases, the air pressure on the parachutist also increases. Now at this point, terminal velocity at terminal velocity, the air resistance force and the weight are equal. So at this point, the air resistance and the weight, they are balanced. So now this is the reason of constant speed or the terminal speed. Now this point, the parachute opens, the parachute is opened at this point. So in some graph, this point act as a point when the parachutist open the parachute, or in some graph you can take this point also. So this point is close to this edge. So parachute open, which increases the air resistance, and now the upward air pressure that becomes more than the weight. So definitely now the speed will decrease. So this curve that shows the negative acceleration or retardation or decrease in speed. So from this speed, now the speed reduces to this point. Now, at this point, the skydiver continues to slow down. Now, again, the speed reduces, and finally, it reaches to the minimum value of speed. Now, that minimum value of speed that continues for a few moments or for some time, and at that time, again, that is a time of constant speed or the terminal speed. So actually, there are two terminal speeds. First terminal speed in this region when the parachutist attain the maximum speed, and then for few moments, for few times, the parachutist or the skydiver that continue with the constant speed or the terminal speed. So that is the first terminal speed. And then just before reaching the ground, before reaching the earth, again the parachutist attain a minimum speed, and then he comes down with that minimum constant speed, that is his second terminal speed. So this is a free fall of a parachutist coming down, a skydiver coming down. The condition is that the skydiver open the parachute. A few minutes later, he jumped from the aeroplane. Okay, so this is all about the free fall. Okay, thank you.